Back at it with the module for the OMC outboard, Johnson outboard. I got some semiconductors in, so I'm going to try and play around with this and see what I can get to happen with it. This small signal transistor right here that I crossed, I dug out some more of the potting material around it, and I noticed when I was moving it, kind of hard to see with the camera, but when I was moving it, I noticed that this leg was moving. This leg of the transistor is moving, so that's actually a bad connection. So I'm wondering whether or not that's part of why it doesn't work, or if that's part of why it may have failed. But what I'm going to do now is I'm going to unsolder that transistor. So what I'm going to do is I'm going to set up my soldering iron and get some solder wick, and we'll take that transistor out. Alright, I got the small signal transistor out. Broke a lead off accidentally, but I got it out, and I removed some more potting material, and I realized there's a diode right next to here. The location of this transistor was Q1. Not that it's going to make a difference, because it's not like I have a schematic diagram or a parts list. But the diode is right there, so I'm going to see if I can't test the diode in circuit and just make sure it's not shorted. Okay, I just tried to check that diode, and I'm getting a reading of 0.127 on my multimeter with it in the diode testing setting. So what that means is either one of two things: either that diode is shorted, or there are other components in that circuit that are across the diode in parallel with it and giving me an erroneous reading. So what I'm going to do is I'm going to attempt to lift one end of the diode out of circuit so that I can test it. Alright, unfortunately that diode is actually cracked right in half. When I went to remove some potting material around it, it completely just moved. And I realized that I probably broke that diode inadvertently when I was digging in the potting material around transistor Q1. So that diode, D1, I don't know what that diode was, so I'm going to have to try and extract it the best I can and see if I can't, under magnification, see if there's any numbers on it. It's a very small glass package diode, so it's going to be tough to figure this one out. Well, one bit of good news: I could see the black stripe on one end, which denotes the cathode of the diode, so I know which way that diode is in the circuit. There's also a little silk screened area on the board. Instead of using a little diode symbol like they commonly would use, they actually use just what almost looks like a resistor, but it's got a little section on one end that kind of gives away which side is the cathode. So I'll know which way to put the new diode in if I can replace the diode. Well, I'll have to work on solving the diode mystery a little later. Right now, what I want to do is I'm going to see whether or not I can actually get any readings on this transistor. I'm just curious whether or not it tests good or leaky or open. Okay, this transistor is actually testing good, but I'm only testing it with an ohm meter. If I had an actual transistor tester, I could test it under full voltage and see if it breaks down or if it's leaky. But that might be a good transistor. Of course, the leg's broken off now. Based on the tests that I just made, it appears that the last lead farthest over to the right is the base of the transistor. So the pinning of this transistor is either it's either CEB or ECB. So now I'm going to compare it to the replacement transistor that I kind of crossed this to, see what I come up with. I was able to kind of cross it based on the specs that the original transistor had to a couple of different ones. One of them that I crossed to, or kind of crossed to, or sub to I should say, is an NTE85, which is a pretty common signal transistor. But I decided to go with this one based on the specs that I read. This is a 2N3417. This is an NPN transistor, 50 volt, 500 milliamp collector current, small signal transistor. It's a pretty common transistor, nothing really special about it. So I'm going to just check and see if the pinning on this transistor matches the pinning in the one I took out. Well, it's looking good. What I was able to determine from the measurements I just took was that that this transistor that I am replacing must be an NPN, as I suspected, because it matches the polarities of the replacement one, which I know is an NPN. the other thing that it tells me is that the pinning is the same. So the base is the far right connection, and it's matching up nicely. So I'm feeling pretty good about this being a good cross for that original transistor. So I can put that in the circuit now. And of course I know which way it went in, but it's also silkscreen. The shape of the transistor is silkscreen right onto the board. Now I just removed the legs that had broken off when I broke off the Darlington power transistor here. This is the switching transistor in the primary side of the circuit, and I know that that went in facing down like this on the board because I can actually still see some of the numbers, the mirror image of the numbers off the front of the transistor. So that went in like this. So let's do some tests on that and see what that tests like. Most of these transistors, the center leg of the transistor corresponds to the tab, this metal tab, which is no different on this one. It usually also denotes the collector of the transistor, not always, but usually. I'm getting a reading from the collector to this far right-hand terminal, which would be the left-hand one from the front. Very low junction resistance in both directions, so that tends to indicate to me a very high probability that's just short. From the two outer leads, I'm getting a reading of like 2 point something in both directions. That I'm not as surprised about because of the strange way that Darlingtons can be when you test them with an ohm meter. Here's what I opted for to replace this transistor, an NTE 2343. It's an NPN silicone Darlington. It's actually an audio amplifier or driver. Collector current 12 amps, maximum collector current 12 amps, 80 watts dissipation, gain of 1000, VCBO of 100, VCEO of 100, and VBBO of 5 volts. So I'm going to try that. Yeah, I'm getting much more normal, apparently normal readings here now with this new transistor from the what I believe to be the collector to the right hand leg. I'm getting a normal transistor junction in one direction and open in the other direction. Across the two other leads, which I'm assuming are base emitter, in one direction I'm getting a normal transistor junction, and the other direction I'm getting like a 1.6 something reading, which again, because of the Darlington nature of Darlington transistors, I'm not that surprised. Okay, so now I've got the Darlington in. I just removed the remnants of the leads from the SCR. Now I say SCR, but in reality I was never able to cross this device to anything. That number that's on it, the strange number, what the heck was it, S616 was the only number I could read off of it. I'll tell you, I tried everything and I couldn't cross it. But based on other circuit designs that do the same job as this, generally you find two power devices as far as semiconductors in the whole circuit. One is the Darlington on one side, which is responsible for taking the 12 volts that comes in and through a switching circuit, stepping it up or bumping it up to a high voltage of around 300 volts. And then you've got the SCR on the other side of the circuit, which is responsible for sending that 300 volts or dumping that 300 volts from a capacitor into the primary of the ignition coil. That's not quite right, but anyways, the general thing is that the point is that I'm pretty sure that this is an SCR. So what I ended up doing in this case here was I settled on a where is it? Here it is. This is a, oh, that's not it. Oh, it's still in the bag. Alright, this is a 576, that's the Mouser part number. This is a part number S6025L. This is a little fuse SCR, 25 amp, 600 volt. And I found a similar circuit on the internet guy basically showing you how to build one of these circuits completely. And he, in his circuit, he used a SCR that had similar specs to this. So this is a good heavy SCR, and I think it will be able to take the punishment if we can get it to work. So now I'm going to take that one out and do some checks on. Okay, my brand new SCR is testing the same way as this SCR that I removed, or the semiconductor that I removed, so that further confirms to me anyways that this is most likely an SCR. The other interesting thing is right now the way it's testing is this SCR looks like it may have actually still been good. But I'm going to go ahead and replace it anyways because I broke the leads off, and not only that, but it's an old semiconductor. The other thing that's nice to know is that the center lead, which is usually common to the tab on transistors, is isolated. This is an isolated tab. That's also the same on the replacement. What's nice about that is that means that I can make this have direct contact through some heatsink compound to the backing plate, which acts as a heatsink, and not have to worry about insulating it. Because if you don't insulate it and this tab is the center pin, essentially you're shorting that center pin to this metal block here. And then of course if you did the same thing on the Darlington, now you get real big problems. The Darlington, I'm going to have a mica insulator in there.